Does anybody in here in Dr. Ju Chong's lab on Monday or Tuesday? Anybody? Oh, okay.
Yes.
So did you hear my lecture? Okay, good. Good. All right, perfect then. It essentially is kind of same thing. So you kind of like repeat in itself. Okay. For those who are not in the lab, I want to say that the reproductive system is a system that is laid dormant uh, until one reaches the sexual maturity, right? And the reproductive system function, by the way, is for reproduction, producing offspring. That's it. You don't use the reproductive system for anything else. Okay? Only for reproduction. Um, okay. Um, Unlike the cardiovascular system, you when you're born with it, you gotta use it right away. Right? You need your heart, you need the lungs, you need the blood, you need the cardiovascular system working. But uh, typically, uh, the in the male, right, uh, is born or child is born so that he can show the primary sex organ. Okay, the primary sex organ for the male uh, would be the testes, okay? And for the female, the primary sex organ, okay, uh, will be the ovaries. And these two um, gonads, if you will essentially uh, is very important in mediating what we consider as secondary sex characteristic. Okay? And secondary sex characteristic is usually not on until one reaches puberty. Okay, puberty. And for those who have listened to this lesson before, what did I say? Is the hallmark of puberty. In other words, what must happen first so that one can consider a child reaches puberty, right? When does a child reaches puberty? Not in terms of age-wise, but biochemically. What happened in puberty? Does anybody know? Um, Anyi? Anyi? Freda?
You
You say
called
you
me,
heard this before?
Prato?
Hmm? So, what is important? How do you know when a child reaches puberty?
When they start developing breasts,
Yes,
pubic
but
hair,
that's usually, huh?
when they start developing pubic hair, breast, and other reproductive,
Enlarged buttocks.
yes.
But that's the secondary sex characteristic in female, right? Which is the development of breasts,
Mm-hmm.
uh, right, known as telarchy, the development of pubic hair for puberty,
Mm-hmm.
and then she started to menstruate, known
Yeah,
as
menstruation.
menarche,
Yes.
right? Uh, but before the secondary sex characteristic, in other words, what is needed to activate the ovary, right, is in fact, this is the hormone, GnRH, gonadotropin releasing hormone. Okay? So in fact, you can say one 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 reaches puberty when the the body started to put out GnRH, gonadotropin releasing hormone. And I told you how the anterior pituitary put out, FSH, LH, ACTH, TSH, prolactin, endorphin, and growth hormone. Well, GnRH allows the anterior pituitary to put out FSH, follicle stimulating hormone, and luteinizing hormone. And it is this FSH that stimulates the follicle development in the ovary. Okay? And the follicle put out a lot of estrogen. And the estrogen then is mediating the secondary sex characteristic, telarchy, pubarchy, and menarche. In LH, we're going to see that in the female has two major functions: ovulation and to maintain the corpus luteum. And the corpus luteum produces progesterone. FSH in the male help in the development of sperm. Okay, they help the Sertoli cell put out androgen receptor, which is helping development of sperm. But LH in the male stimulate the interstitial cell to put out testosterone. And testosterone, under testosterone, the male has secondary sex characteristic, which include increases muscle mass. We all know this. Okay. Increase aggressive, facial hair. Yes. And increases the larynx. Right. So the larynx will get bigger. So the voice will get deeper. You can, the child can hear a cracked voice. So your baby no longer your baby. Is beginning to become a man, if you will. All right. So GnRH is very important. That's what I'm hoping you to learn, is that puberty, or the hallmark of puberty, is to increases the GnRH, gonadotropin releasing hormone. Right? And gonadotropin releasing hormone allow the anterior pituitary to put out FSH and LH. And all right, so then that's indicated here. So reproductive function really, began, for both male and female. GnRH will be very high, but the function of FSH and the function of LH is different in male than in female. Okay, in male, LH stimulate the interstitial cell or Leydig cell to put out testosterone. LH in the female has two major functions: ovulation and to maintain the corpus luteum, which is put out progesterone. Okay, that's a two important function of LH in female. All right, so hypothalamus controls the maturations of the sperms and development of male secondary sex characteristic. So what we're going to do is we're going to look at the male reproductive function first. I hope I can finish it in the male. And then next week, we can start talking about the female and development. Okay? And typically, like in the endocrine system, it's a negative feedback. So if you can see here, the hypothalamus that put out allows the hypothalamus put out GnRH, allows the anterior pituitary to put out FSH and LH. LH goes to the stimulates the testes to put out androgen or inhibin, and both of these negatively feedback, so that the hypothalamus either do not put out GnRH or the anterior pituitary do not put out FSH and LH. And you can see here the functions of FSH stimulates meiosis in the primary spermatocyte to form immature sperm. So next time we're going to see that it's FSH, it's involved in the development of sperm, known as spermatogenesis. Okay, spermatogenesis. In the development of sperm. So we call that spermatogenesis. And see LH here? LH will stimulate the interstitial cell to put out androgen, and the androgen here is known as testosterone. Okay? Interstitial cell, sometimes I use interstitial cell, or sometimes I use Leydig cell. It's the same cell. Leydig is a guy's name, but it's a interstitial because it just sits outside the seminiferous tubule. Okay, and androgen, prevent over secretions of LH, inhibin prevent the overstimulations of these FSH, basically. Just a negative feedback. So under the influence of testosterone, this we call it secondary sex characteristic, right? So the boy have reaches puberty, increases growth of body hair. You could lose some of the hairs in that scalp, enlarges larynx, thickening of the skin, increased muscular mass, thickening and strength of bone, also increases sebaceous gland secretion. So if this is infectious, it can lead to acne. So, teenager, typically what you see. Acne is in the face of a teenager. I think most of you might have acne, and if you don't keep it clean, usually they go away when you get older. All right, what are the organs of the male productive organs? You're starting out, the primary sex organ is the testes, right? This is known as the epididymis, and the function of the epididymis is to store the sperm. The testis is the area that make the sperm. You store it in the epididymis. And during the ejaculation, the sperm comes out through the vas deferens, and the vas deferens opens up into the ampulla, and then it dumps it into the ejaculatory duct. And then that, at the ejaculatory duct, it will join secretion from an accessory gland known as the seminal vesicle. The seminal vesicle secretes semen, but also with fructose, right? So the question might be is, what glands secrete semen and fructose to support the sperm? The answer is the seminal vesicle. And then those semen plus the prostate, and this prostate is defined as this accessory gland that sits inferior to the urinary bladder. It also secretes substance that activate the sperm, right? So that's part of the semen that comes out, and then the semen then flow through the prostatic urethra, membranous urethra, and out to the spongy urethra. So that's one exam question to ask you for the route of the sperm flow in the order, right? Epididymis, vas deferens, ejaculatory duct, prostatic urethra, membranous urethra, and spongy urethra. Okay. There are other accessory gland known as the bulbar urethra or Cowper gland that sits in the membranous. It secretes a substance that will lubricate the um, the penis, if you will, so that allows us for easy penetration in the female vagina. Now here is the posterior view of that drawing to show you that the seminal vesicle that secrete the semen and pretty much alkaline substance and fructose. Okay. The Cowper gland or bulbar urethra sits in a uromembranous region. The erectile tissue that you see here too, these are known as corpora cavernosa. Inside this will be deep artery. So under the influence of the parasympathetic nervous system, okay? Not sympathetic, but parasympathetic. In fact, you know what you should think of? Erection, the male erection, which meaning that the deep artery, so if you do a cross section of this, okay, of the penis, you're going to get this structure that looks like that. Like Mr. O, where this right here is the deep artery, okay? Artery. Whereas this, that's the opening to the urethra. Now, the erectile tissue that important for erection is this one right here that surrounds the deep artery. In fact, the deep artery under the parasympathetic nervous system will release nitric oxide. And nitric oxide causes the artery to relax. So then it engorges, relax, so more blood can reach the area. Okay. So more blood will come in. And if you get more blood, this area will become hot. Okay. And then it's become hard, you get an erection. At the same time, this right here is called corpus, the erectile tissue that surrounds the deep artery is known as the corpus cavernosum. One of them is two. It's known as corpora cavernosa. All right. Corpus cavernosum. Okay, so okay, I can show you next time where it is. And this right here is corpus spongiosum. Okay. It also will be engorged with blood. Okay. And this is just basically create a buffer so that the corpus cavernosum or corpora cavernosa doesn't push on the urethra, for example. And it is the parasympathetic nervous system. Parasympathetic nervous system that is involving erection. And when the gland of the penis, which is this right here, it stimulated, excited, so that there is no, once the guy reaches threshold, for example, he can have an ejaculation, right? Um, and ejaculation is mediated by the sympathetic nervous system. Okay. Now, this is easy way to remember this is that erection, think like if you go in hunting, right? Erection is kind of like pointing a gun. So pointing, okay? And ejaculation is same thing as shooting. So pointing, parasympathetic, shooting, sympathetic. That's how you remember it, right? So don't get that wrong. Okay, now the gonad that you see here, the testis or testes, is you get both of them. Typically um, develop wise near the kidney, and towards the third term of pregnancy, the um, the gonad is descending, is guided by the gubernaculum, is descending into the sac. So this shows you the descendant of the testes. During fetal development, each testis is developed near the kidney, then descended to the inguinal canal into the scrotum. But what is controlling up is the gubernaculum ligament that is actually holding, pulling it down. You can see that. And then by birth, it dropped into the scrotum, if you will. Okay. Now, and it actually goes through the inguinal canal. That inguinal canal is has what we consider spermatocord. So the spermatocord would have the gubernaculum, but it also has testicular arteries, testicular vein in there, vas deferens. All that is travel in the spermatocord. Okay. Now, if the testes, however, do not descend, okay, they just sits there, then a kid might develop a condition known as cryptorchidism. Okay. Cryptorchidism. Okay. The word crypto, does anybody know what the word crypto means? As in, where does Superman come from? Does anybody know where Superman come from? Krypton, yeah, Frida, yeah. So you know what the word krypton means, right? It means that same root word crypto mean hidden. So Superman planet, you can't see it because it's hidden. All right. Now, if in the boys with cryptorchidism and is not being surgery with surgery to help it guide into the scrotum, the child tends to develop testicular cancer. Testicular cancer. So basically, the cells started to divide. And normal spermata development, usually it's at a 2 to 3, maybe 4 degree lower than the body temperature. Okay, in the scrotum is further away, so it's at the uh, lower temperature. Now, where does the sperm is made? It's made inside this right here, known as the seminiferous tubule. Seminiferous tubule. This is a seminiferous tubule. Okay. Now, within the seminiferous tubule, there are the cells known as sustenticular cell. Okay. So sustenticular cells or these are the same thing as Sertoli cell, are in the seminiferous tubule. Right? And under FSH influent follicle stimulating hormone, FSH will stimulate the sustenticular cell to produce androgen receptor. In other words, when they say androgen here, they're talking about testosterone, androgen receptor. Okay. And see these cells right here that sits outside the seminiferous tubule is are Sertoli cells, sorry, are Leydig cells or interstitial cell. Now, if you give these cells LH, luteinizing hormone, okay, LH, these cells started produce testosterone. Okay. And testosterone will bind to estrogen receptor in a way tells the Sertoli cells to help the development of sperm. And the sperm are usually have different stages of the sperm. So I'm going to spend some time to talk to you about the sperm development. Right. Okay, now if this is the seminiferous tubule, there is different stages of the sperm that is going slowly from the outside and it go inward. Okay, and the stages of the sperms are, again, you guys need to know the order, right? And the order is spermatogonium, is the cells that has two sets of chromosomes, we call it 2N or diploid, which then give rise to primary spermatocyte, which is is still a diploid 2N, and the primary spermatocyte will give rise to a secondary spermatocyte, which is now is a haploid, which is n numbers of chromosome. And from secondary spermatocyte will give rise to spermatid, and spermatid, which is also a haploid, then undergo further development to give rise to the sperm. And definitely the sperm is a haploid. Okay. So the process by which how a diploid cell, which is this, give rise to a sperm, which is a haploid cell, okay, in this sequence is a type of cellular division known as meiosis. Okay. Meiosis is a type of cellular division in which one cell, which is a diploid, will give rise to four cells of half numbers of chromosomes. Okay. And this is known as meiosis. And meiosis occur only in the primary sex organ, which is the testis or the ovary. Right? So this is meiosis. Now, this is relative to what we consider typically in mitosis, and that is, in mitosis is a type of cellular division in which a cell, which is a diploid, that give rise to two cells, that is, two members of the chromosome. All right. So that's how you can compare between mitosis and meiosis. But in meiosis, the development of sperm are in order from spermatogonium to primary spermatocyte, secondary spermatocyte, spermatid, and sperm, also known as spermatozoa. Same thing. Okay. So in mitosis is in fact it just basically single step, whereas in meiosis, single step means you go continuously from a diploid to another two cells, a diploid. But in meiosis, in fact, there are two different steps, if you will, two different processes. The first one is known as meiosis 1. And then the second step is known as meiosis 2. Right? Meiosis 2 is known as equatorial division. And meiosis 1 is known as reduction division. So this is broadly shows you the difference between mitosis and meiosis. And the reason why it's called reduction division is that the chromosome now is half. So for example, the primary spermatocyte, which is a diploid, undergo meiosis 1 to become secondary spermatocyte. And the secondary spermatocyte only have a half numbers of chromosome. Okay. And so these cells right here will undergo meiosis 1, right? So always keep in mind, meiosis 1 is reduction division. And since how secondary spermatocyte still have the two chromosomes stick together that now pulls apart, right? And so secondary spermatocyte goes to spermatid, is the cell undergoes this meiosis 2, right? So that's easy to remember. Primary spermatocyte undergo meiosis 1, secondary spermatocyte undergoes meiosis 2. Okay. Now, in fact, what I've done is I already have a lecture. We'll go into details about mitosis and meiosis. Okay, and I'm going to share with you pretty soon. So you can listen to that to learn more about mitosis and meiosis. All right. But to note that meiosis is a type of cellular division that gives rise to the sperm. So another way to think of what is the functions of meiosis. Meiosis is not only in making the cells that have half numbers of chromosome, which is good because if you imagine that, so the normal process that the sperm has a half numbers of chromosome, the eggs have half numbers of chromosome, together you make a diploid again, okay? And then it goes to mitosis, two cells, one cell to two cells to four, and they have exactly numbers of chromosome. Now, If meiosis doesn't occur, can you imagine a cell that is a sperm, which is 2 chromosomes, with the egg with 2 chromosomes? They join, they become um, 4 chromosomes, right? And then a cell that has 4 chromosomes meet with a cell that has 4 chromosomes. Now you have an 8-cell chromosome, and pretty soon you can have a cell that has too many chromosomes, and it usually dies. Okay, so meiosis allow for to make these sex cell have numbers of chromosome, and together we would call it a sexual reproduction, not asexual but sexual. Asexual reproduction would be like, say, one bacterium make two bacteria and so forth, and they have exactly numbers of chromosome, right? They don't change. But in sexual reproduction is important. It's because there's allelic exchange. DNA can swap each other, and that is the functions of meiosis, which allow for the DNA exchange between the chromosome, okay, as part of the tetrad, which is part of the prophase one of meiosis one. Okay. I encourage you guys to listen to this recording about mitosis and meiosis. All right, so I'm going to stop there. And then next time we're going to pick up here and show you that in the development of the sperm occur in the seminiferous tubule, and how you can see here. Okay, so this is just a section of the seminiferous tubule, right? And you can see how these are different stages of the sperm development: spermatogonium, primary spermatocyte, which is a 46 chromosome, but just, right, and then give rise to two cells. Secondary spermatocyte has 20 chromosomes, but these 20 chromosomes is already duplicated, right? So it still hold on to the sister chromatids, right? So it's 23, but it's no longer pair. It still has this, okay, which we call it sister chromatids. And the sister chromatids need to be pulled apart, right? The sister chromatids must be pulled apart so that now each one of these will give rise to these two cells. Okay. Then you got your 4 cell, and then from the development of um, the these spermatids, right? These are known as spermatids. Spermatid here give rise to spermatozoa, which is a nice sleep machine. There's additional process here known as spermiogenesis, and spermiogenesis is to go from here to here. Okay. This is spermiogenesis. And notice how this is the division. That's one cell. That is the sustenticular cell. Here's another sustenticular cell. This is the nucleus of the sustenticular cell. And you see how the sustenticular cell help in the development of sperm. But another important thing of the functions of the sustenticular cell is that they produce this right here, the blood testis barrier. It makes the blood testis barrier. Okay. So in other words, as the male is producing new, potentially sperm with new protein, if the body is exposed to this protein that was not been tolerant early in life, you're going to reject it. And so to prevent the rejection, you have to have this isolation, okay, this tight junction that sort of like prevent these cells from ever exposed to the blood. All right, I'm just going to be ended there. And then next time I'm going to start with this spermatogenesis and shows you, if we go through different steps between first meiotic division, known as meiosis 1, versus a second meiotic division where you're separating the sister chromatids to give rise to these. All right, so are there any questions? Okay, if there's no questions, I'm going to end it here. And I'm going to post a recording for you to compare and contrast